Yo, yo, yo. Let's go. New week. What's up, Devioli? Yeah, 9 a.m. Central European time. Summertime, maybe. I don't know. That's when we start each weekday. Good morning, Harukanan. By the way, Devioli, nice shader result you posted on Discord. Unfortunate with the 100 render batches though, but should be able to get that down, right? Good luck with the applications. I'm not sure I can get it down. Yeah, the question is if you can get it down without reducing the visual quality or not. Okay, over here we're gonna do not as cool, but maybe just as fun stuff. We're gonna take this very nice result we got last week from the... Why do I always forget the name? Midpoint circle algorithm. And we actually structured it pretty good. And we might want to clean this up today and then see if we can actually use it for something. So that's what we're gonna do. So point row. The algorithm in the end looks a little bit like, or looks exactly like this. It's pretty nice. So we get the origin, we truncate it, because if we truncate it, the origin, we know that the circle is symmetric and we can simplify the calculations quite a bit. Good morning, Geralt. Hope you had a great weekend. There is a big issue, let's see. Draw render command. Okay, so if each of them are using the same material, but you only have a but the only difference is the color value. Have you instanced the materials? Like, have you done like, have you done anything with instancing? Because that might get your draw call count down. Or actually add 100 render batches. Okay, so after the origin is truncated, we just calculate the points for one octate, and we do it for the octate that starts at 0 degrees and goes up to 45 degrees. But that's not here. That's in, let's see here, points, calculate octant points. So we get the start point, truncate this one, and then we get current point, primary direction, secondary action, direction, and then we just loop through it. We get all the points for the first octant, and then we do some very nice link. So we take the points and we add, like, we duplicate the points and we mirror them by switching the x and z coordinate, and that way we get the second octant as well. Then we order them by z and then by x, and then we group them by z, and then we just take the points for each row that has the biggest x value. And when we have that, we mirror them again, so we get the lower right quadrant of the circle, and then we create point row by that. So when we create point rows, we basically get the left side of the circle as well, and then we just draw it to get this nice result, because now we have a circle of the grid, we have a start point and an end point, and that is hopefully things we can use in the terrain. Let's see, it should be instanced, okay. Draw renderer. So is it this one? Yeah, I understand that, Jolly. Good luck with the applications, and good luck with this problem later on as well. Okay, so right now we create these points and we save them as this struct, and that is the struct we're gonna use. But first of all, I just want to clean... I wonder if I want to clean this class up or just create a... and probably clean it up, rename it, and then actually use it. Maybe we could... okay, actually, this is how we're gonna do it. We're gonna take the best things, or the things we need from this class, and we're gonna put it into a static class with some nice functions we can call. Yeah, that's the first thing we're gonna do. So we're gonna convert this to a class we can actually use. I'm gonna keep this one though, because we're gonna replace a lot of these things with calls to the static class and see if it works. Okay. Let's create it at environment terrain. Probably want it here, I think. I think I'm gonna name it grid point getter. For now, it will work. And I think I want a function like this, I think. Let's see here. And we're gonna add a grid point range, grid points range. Grid point range or grid points range? Yeah. And this one is basically going to be the equivalent of this one. Let's see here. Start point, end point, number of steps. Grid point range. Yeah. Origo endpoint. Not a big fan of this name. Let's see. So it's the endpoint for this row. But non-offsetted. Centered endpoint. Let's remove this here. Okay, so then I want, in grid points getter, I want to have a method that, let's see here, returns grid point ranges. Get grid point ranges. within circle.
Actually, circle arguments are going to be the second line. First, we're gonna have grid arguments. And what do we need for our grid arguments? We need, okay, this is for circle settings. Grid size, we need, what do we actually need? Is it just a delta? I wonder if we need a delta offset as well. Or should we just always assume that each grid is at 0? And for now, something one could think about as well is, do we want to support a grid that has a different X and Y? Nah. I don't think so. Grid delta. Is these the only... Is this everything we need? Let's find out. Circle origin truncated, yes. If circle radius I guess we could just do, okay, maybe not. And origin truncated, this was the circle origin truncated. And I'm just gonna replace this one and grid delta. Here we create the visual grid. We don't want that one here. Yo, what's up, Fabic? I'm doing good. Starting to get warmed up, you know, Monday mornings. And yeah, I had a nice weekend. A non-productive one, but a nice one. Hope you had a nice one as well. And then we want to do this, calculate octant points. Let's see. Oh, here we go. Do I want this as a separate function, or should I just include? Maybe I should just include it, but let's see. So we have a start point. We don't need this one anymore, right? Fuck, I hope we don't. we should not need this one anymore. Okay, let's just take this one and put it here. It's a static method. This function or this method will do a lot of stuff, but it almost feels like it's more readable if we just keep it all in one method and wait with splitting it up until we notice that we might need some of this functionality in another place. But let's see here. Start point, radius, circle radius right. And then we do start point truncated. Current point. I'm gonna keep this one for now, and we're gonna log it. Hopefully we can remove it later on. It's just a failsafe. So if current point Z is less than current point X plus an offset here, which is based on this is basically an error, then we stop here. And we have get next point. Let's see, get next point. Yeah, let's mash that into here as well. Points add current point. Then we're gonna try and calculate the next point. Current point is equal to this one. Get radius error. Oh, that is one thing I forgot about. We can also try and optimize this method a lot, I think. Let's see how hard that would be before we continue with this one. So back in midpoint circle algorithm. We have get radius error here. Right now we just calculate, we use the circle function and basically check so this plus this should be equal to this if the point is on the circle. So if we take this plus this minus this one, we get the error of representing the circle, and by using this one we can figure out which direction we should move in. But I remember reading about some optimization here, because this actually includes 3 to the power of 2. This one we can cache, of course, but we might not even need to do that. We will see. And then we have an absolute as well. So let's see if I remembered correctly. So here I think it is. So this is the radius error. And then they simplify it. They simplify it with, so like we do, this is direction 2, so x minus 1, y plus 1, and this is direction, actually, what is it? This is the primary direction, this is the secondary direction, and this is how we call it. But so like when they simplify it, they actually add the x minus 1, y plus 1 here. The absolute value function does not help, so square both sides since a square is always positive. Okay. So here we just rewrite this one, simplify it a bit, or change the order of stuff, I assume. Same here. And then we add to the power of 2 to all of this, so we get this. We don't add. Okay, so this one is equal to this one. Okay, I think this simplification is pretty straightforward. We assume this, and I think we can do this as well because we're working with the same octant. Okay, can we use this? Okay, so this is 2 times the radius error of the start point, or we change this one, right? Plus y change and x change. And bit shifting for the multiplying by 2 operations. Okay, so it's actually 2 times the radius error of the current point plus, but then again, to simply integer addition, subtraction, and a bit shifting. Okay, let's do this simplification first. I'm a little bit more skeptical to this one.
So this should be okay. We should be able to replace, let's see here, get radius error, get next point. Let's try, do we have a fail-safe up here now if I'm going crazy? Angle check less than, or actually it's down in calculate octant points. Yeah, we do. Okay. Okay, so we still want to use this one here. So return, and what do we want to check? If this one is bigger than 0, so 2 times get radius error for p right plus y change. Okay, we can't do and y change is what did I name it? Calculate octant points. Okay, secondary direction has both of them, so let's go, yeah, plus, was it offset 2 dot z, and then we also add x change, so that's offset 2 dot x. And if all of this is bigger than 0, then we return segment point. We just want p here. So if this is true, then decrement the x value, keep the same x value. So that's p plus offset 2, otherwise p plus offset 1. I think. Do we have an error or? Okay, that's not true. Okay, so what mistake did I do? So the result we're seeing here is that we always decrement the x direction. And I wonder if that's because, let's see here. X change. Or actually, let's see. Okay, they replaced this one with Y change and this one with X change. So it's not only the change. Okay, good. So 2 times. So my mistake. Instead of doing this and this, we want to do two times two. Actually, how do we have that one? Yeah, 2 times p dot z, right? Plus 1. Vector 3, what am I missing? 1 parentheses, yes. And this one we want to replace with one minus 2 times p dot x, I think. Okay, so something like this. Let's see here though. Interesting. Although, okay. Then decrement the x value. It's offset 2 had the decremented x value, I think. Primary direction does not, secondary direction does. And I do primary, secondary. I'm still wondering about this step here. Get radius error is segment point x to the power of 2. That one is correct, and then we have 2 times this one plus 2 times p z plus 1. Ooh, okay, let's see here. Are we having a problem with this simplification because we're not working with integers? Oh, yeah. But can we convert it to integer based?
Okay, well, let's see here. Let's do. I'm gonna put a note here. So the end goal is to actually work in an integer space because we want to work with indices. So we might use this one later on. Okay. Okay, so we do this one, P1, P2. Get radius error. And when it comes to radius, we have it there. So let's do points. Current point, primary direction, secondary direction. Current point is equal to, okay. And here we do, I think it's current point, and primary direction, secondary direction. Now when we have all the points, appreciate it, Fabic. Arthdev Life, what's up? Yo, yo, yo. Hope you had a wonderful stream. Okay, calculate octant points. We do all this. So we get to this point, and then we want to take the points, mirror them, sort them, mirror them, sort select. Yeah, let's do it. Arthdev Life, I lost you for a minute. Yeah, I said what's up and thank you so much for the raid. And then I also said I hope you had a good stream. If I remember correctly, you raided me, when was it? 5 days ago. I think I was doing sort of the same stuff 5 days ago as I am now. So no difference here. Yeah, I had. Nice to hear. Well, actually 5 days ago might be... Yeah, anyway, we're currently trying to get the terraforming in place, so altering the terrain in hopefully real time. And we're working on the selection algorithm, so a way to select the vertices that will actually change. It has been an adventure, to say the least. Okay, so we create points, calculate them for the first octant, and then we do some nice link calls. I think it's pretty cool. Let's see here. Why is it complaining here? Oh yeah, we try to make it into an array, I guess. Or do we? No, we don't. Oh yeah, let's do IEnumerable vector 3 points. And let's be explicit here. Is it append? Fuck, is append extremely costly, or is it the same as... it should be okay. Should be the same. Okay, so we create a list of the points, then we mirror them and add them, do some sorting, and we select the last one, and then we do some mirroring there as well. And then finally, we're gonna create an array of not point row, but grid point range. And actually, I think we can do return here. So points, order by, select, and for each point we create a new grid point range, and circle origin truncated, the point in question, and here we have grid delta to array. So we should be able to rely on this method here, and it's static. So like if we have a grid defined at Origo, so we're this, or like, let's put it this way, if we have a grid non-offsetted, so it has 1 point in Origo, then we can use a function like this. So we just send in the grid delta, so this is both
X and Z direction in our case. Yeah, that's pretty much everything you need to define a grid, I would say. So we have the grid, then we do the circle origin and the circle radius of the marker. And truncate the circle origin, calculate the start point, truncate the start point, set the current point, primary direction, secondary direction, and we cache circle radius squared, so we don't need to do it multiple times. And then we do the midpoint circle algorithm for the first octant. Then we do some mirroring magic and sorting and stuff like that, and then we create a lot of grid point ranges, and then we return it. So now let's see if we can rely on this method within our midpoint circle algorithm tester. Fanny Slam Arth Raid, yes indeed. So I want to replace a lot of things here, but let's see here. We want to draw this still, and let's see. Yeah, I think I pretty much want to comment out this. So right now we just draw the grid, and then we're going to rely on, let's see here. Grid delta is delta, circle origin is, fuck do I call it? Should have it. Start origin. Is that so? And radius. So this is hopefully everything we need to do, and then we can do, we do I here, ranges. Hopefully I didn't screw this one up when I re-implemented it. But I did. Okay.
Harukanan, farming yeehaw. What the fuck is that supposed to mean? Right. Understandable. Well, crop circles. Okay, I'll allow it. Semi-correct chat. I wonder why. Why? Let's see. Calculate octant points. Origin truncated here. Ooh, is that it? We did the same here, I think. Yeah. P and delta. So, do we get any prints here? Yeah, we do. Yeah, we get T prints, but not. So debug.log ranges length seems to be empty. I'm just gonna comment this one out. Yeah, okay. So now the question is, when does it become empty? Do we have any points here? Refuxo, thank you so much for the follow, appreciate it. There we go. I have a feeling that one variable somewhere got changed. Circle origin, grid delta, circle radius. Let's see here. Delta here is grid delta, start origin, circle origin radius,
radius. Ooh, actually, I think I might know. Or do I? Okay, so we get to here, but we have points is empty here. So this one fails instantly. That's interesting. Current point Z is less than X. Okay, so I guess I might have screwed up this one. What error did we use here? Calculate octant points, we do delta. I don't see how this fails. Fuck yeah, I know. Jesus. I'm pretty sure this is it, right? In the nature of link, that's how you should do it. Yes. Okay, there we go. So I'm a little bit worried, to be honest, about the performance here. But I don't know. Link append performance. Would like to see like a comparison with just having a list and add. Like, I wonder if I want to do skull tag. I would assume append is a lot faster than add. I hope that's the case. And good morning, by the way. Let's keep it for now. Don't think it matters that much, but maybe. Like, when we compare this solution, like get grid point ranges within circle, we're also going to do a similar function that is get grid point ranges within square. And when we compare the performance of those two, like there exists a couple of things we can optimize with this one. But yeah.
And I think I'm also going to, I'm pretty sure I can remove the failsafe of T right now. I hope so. So this one. Am I gonna... No. This one is the fast direction, so yeah, we don't need this one. Great. Okay, nice representable method. Let's just see. Calculate points in first octant using midpoint. Yeah, let's keep it at that. Okay, so given a grid, all we do is call this function, and thanks to the constraints we have applied to the grid, and the method, the approach, the only thing we need to send to this method is the grid delta. We assume the same delta in both directions. The origin of the circle and the radius of the circle, and what we get back is all the points within that circle for the grid, but represented by ranges. So I think that's pretty nice. Insylas, what's up? Yo, yo, yo. So that is pretty nice. Am I ready for this? Let's see. Yeah, let's do Skulltag, you can make it faster. Yeah, I guess we can. Please do tell, please do tell. I think we're gonna go. I have some, let's see here. Do I want to? Okay, let's do it like this. We have a list of possible optimizations. Let's just order it. Add method in terrain path for getting affected vertices. Add midpoint circle algorithm approach. So I like to do things the other way around. So right now we're creating tasks that are already completed.
grid points getter. Implement implement ranges within square. Insulos, would you read my Reddit game idea and tell me how hard would it be for a guy with no experience to do it? Sure, might not have the time right now though, but send it in PM and I might hit you back. Skulltag, you know the physics function of Unity like SphereCast. There are different variants for it, SphereCast and SphereCast non-alloc. You can make the function like the non-alloc. So that is should have SphereCast non-alloc. It stores the results into the user provided array. Okay, yeah. For us to be able to do this, we need to be able to calculate the size. We don't. Fabic going into lurk mode, have to get some real life quests done. Sad face indeed. But appreciate the lurk and good luck with the real life stuff. Yo JD, what's up man, what are you working on? We're working on terraforming of the terrain, and we're more specifically working on the algorithm that will calculate the affected points of the terraforming. Yeah. Let's see, not really. The user provided array should be larger than the result. You see the int return value, that's how many elements of the array contain relevant data. Yeah, okay, so if we implement it in this way, we need to know like we need to, when we call the function, we need to add a we need to have some idea of how many grid range objects or structs or points within the circle we are gonna get, right? We need to have some idea, isn't that the case? But yeah, definitely. Like, let's add it as a note at least. And yeah, the benefit of this is just make one array over and reuse it over and over. Okay, so you mean... Ooh, so you mean like in grid points getter we could create an array, like we create an array on startup and we create the array in a way that it's as big as the maximum number we will ever fetch, and then we just return that one all the time. Is it something like that you mean? And Cartoons TV, good morning, happy coding to you as well. JD, do you know how to script in Lua? No, unfortunately not. And Derek.net, keep up the good work. When can we expect the next devlog? $5. Thank you so much. Extremely appreciated. As to the question, when can we expect the next devlog? Hopefully within a couple of months. Oh, I want to be optimistic about this one. In June, I think. And after that, the idea is to actually produce them in a quicker fashion than I already have. But yeah. Thank you once again for the donation. Yup, you will need to make it larger than you will ever expect to get. Yeah, exactly. Yeah, we might... I'm gonna write it down in the to-do list and we might jump onto it. I think when it comes to this get grid points range within circle, we are gonna have to optimize this quite a lot to make it more performant than just a square approach. But I don't know, we will see, we'll see. In Silas, I posted it on Discord. Is that okay? Yes it is, yes it is. Thanks for the response, man, inspiring work, can't wait. Thank you, thank you. Okay, so let's add some more tasks here. This one is already done then, but so... possible... optimize... let's see here. By... minimizing... optimize by minimizing, reallocating list and arrays. That should be included. We can do it like this. And I had one more thing in mind. We can't simplify the radius error function anymore. Than we currently do. Not until we move on into integer-based space. But did I have one more thing I thought about optimizing here? Maybe not. Maybe not. But what I also want to implement is, like, one of the biggest optimizations that could be done to this one is probably, hopefully, a function of implementing grid points together, get grid point ranges within circle, get grid point ranges within circle, get grid point indices. Is that how you spell it? Get grid point indices ranges within circle. Because if we can implement this one, so what I mean by this one is that we don't work with points in world space. Instead, we just work with pretty much pixels. So we should be able to get this. It all depends on if I have the brain power to do it. We'll see. What were you trying to use the points for again? I forgot. Yes, terrain terraforming. Wouldn't this be like 100 times faster with compute shaders? Probably would. Or like it depends. It depends. Right now, I'm currently in the process of implementing terrain in with three different approaches. One of them is compute shader adjacent, but like you still need like a lot of information on the CPU side, and my experience with compute shaders is non-existent. So we're gonna make this work like this, and then we might explore it. I don't really know yet if we actually need to rely on compute shaders. What's up, Top 5, by the way? So when we actually do the terraforming, we're gonna, in this approach we're working with right now, we're gonna do some work on the CPU and some work on the GPU. Split it up like that. And when it comes to visualizing these points, we're actually going to implement a shader that basically does the same work as this one does for visualizing it. We'll see. Okay, so like if we would be able to implement a function like this, get grid point indices ranges within circle, then that would be the biggest optimization of all with the current solution. Because if so, then we can optimize by using a better radius error by using a simplified radius error function, and the other one is implied by this, so we're gonna keep it like this. Okay, so now what do I want to do? Now I want to use this one within, let's see here, action terraform. So every time we call this one or this one, or actually every time we call this one, unfortunately it's this one and this one, but let's see here. Yo, Dev Spires, thank you so much for the raid, appreciate it. Okay, so what we have here is the character action that will actually do the terraforming. And this one is controlled by the player, mouse position and scrolling to scale. And it's this pointer that this one uses. Right now it's just using a Terraform visual point. It's this one we want to use to calculate. It's Terraform visual, actually it's Terraform point and Terraform point scale we want to use to fetch the affected points. Macrosamia, yo, I'm learning programming at school. Yeah, I can understand that. Staying motivated. Like the ever returning question, right? To be honest, I've just like conditioned myself to not rely on motivation at all. So, or not at all, but rely more on discipline than motivation. That is pretty much the only tip I can give. Like, it's hard to control motivation. It's easy to, or it's easier to control discipline. But yeah, good luck with the Python studies. Just keep at it, yeah. Let's see here, action terraform. So, the hard part here is that we need to remember that the terrain we're working with is actually multiple terrain patches. So what we need to do first is and this is another thing as well. Okay, so there's a few things here. We want to fetch, let's see here, I think I have a circle selection to terrain indices. Truncate P based on terrain grid. Mirror, yeah, remove intermediate points. Exactly, order points as start point and end point pairs, offset the point using the truncate P, convert remaining points to indices. We're almost there. Midpoint circle, given a marker point P and radius R in world, we want to get indices of terrain vertices. So there are a couple of steps here I want to add. And they are related to let's see here, to our terrain. So first of all, we actually want to do circle selection, yeah. Overlap, or actually call physics, is it overlap sphere? Based on P and R. I want to put this one as convert colliders, or actually get terrain patch components from and then I think we want to do I want to do this for each terrain patch basically, but this will do for now. So we need to get the terrain patches we're gonna alter, and we're gonna do it with overlap sphere and then terrain patch. And then we get the terrain patch, and for each terrain patch we also know the terrain grid. Although, let's see here. Yes. We will never have a case where the terrain patches have a different delta value, I don't think. But yeah. Convert remaining points to indices. The worst part here is going to be remove It's a little bit of a mess here right now, but there's a lot of things that I have to keep in mind when doing this. So let's start by just doing this and this, and when we have the terrain patches, I'm thinking of doing let's start by doing this. And unfortunate. Ooh, actually. Decisions. Yeah, it's a question of how one wants to visualize this as well, but okay, let's do private void update like I'm wondering if okay, let's do private void update how is the terrain rendered? Are you just changing the mesh and using a default shader, or did you make your own shader? in the naive approach we have, we are changing the mesh, and we're using, or actually for all the three approaches we have, we're using custom made shaders. For the naive approach, we rely on calculating the vertex positions, normals and tangents on the CPU. In both of these approaches, we pretty much just create one grid mesh, and then we render that at different positions, and we offset it, calculate normals, calculate tangents and everything on the GPU. Why are you doing many versions? It's a learning experience for me, and yeah, I want to be able to compare performance as well. Yeah, I mean, my knowledge about terrain and terraforming and generated terrain and such was pretty basic before I started doing this. Like, I knew pretty much how to do it the naive way, so this one was pretty much straightforward and easy to implement. Trying to offload more things on the GPU and such was entirely new to me, and like, it's been a very fun adventure so far, and I'm shocked to say, but right now I'm very impressed by the naive approach. Just like right now it looks like this is the approach I'm gonna rely on. But we'll see. Everything can change. Update. Let's just call it marker for now. I don't know why I'm spending so much time on. So I'm gonna do a very, very simple marker here. I'm pretty much just gonna do, within this one, we're gonna, let's see here, we're gonna instantiate, I don't know, 50, yeah, we're gonna instantiate 50 spheres, and then we're gonna use those spheres to place them on the vertices we get from the terrain patches. That's what we're gonna do to visualize this marker. I thought I knew a lot about it too, but I saw a video lately that showed some techniques that just showed me I knew nothing and been doing everything wrong. Yeah, I recently saw a very nice video on YouTube about optimizations when it came to terrains, and yeah, it made me realize how little I actually know about this. But then again, depending on the use case as well, like for my use case, I'm not going to render extremely large areas of terrain. We're not talking 1 kilometer maps here, or tens or hundreds of kilometer maps. At most, at the very, very most, I think we're talking 1 times 1 kilometer. Video is called When Your Game is Bad but Your Optimization is Genius. Thank you for the tip. We'll definitely take a look at that one. Okay, so do what did I want to do here? Game object, visualization points. Like this song as well, The Strangest Thing Illiterate. Yeah, let's save that one for future videos. What did I say? The strangest. Transform local scale, and then I also want to do dot set active false. Update marker is what it's called. Yeah, whatever. So update marker. Yeah, let's just pack all the logic within this method for now. So what we want to do is we're going to do some physics raycast. What is it? Collider. Colliders is equal to physics dot overlap sphere. Terraform point. Oh my god. So change visualize pre-terraform scale. So this is only for visualizing it. Update terraform point. Okay. No. Terraform point scale. Yeah, here we have it. But then, let's see. Private void visualize pre-terraform action.
And then I actually want to call this one update terraform point radius. Maybe. Okay, so terraform point, and although terraform point scale, is this the radius? Let's see here. This is a primitive with 0.1, but a primitive spheres have a radius of 1, right? So the scale should be the radius. So like this, and then we do I guess we can do something like for each and then we do terrain patch. If terrain patch, can we check it by just doing if terrain patch continue? Okay, so now we have a terrain patch, and this is probably where we want to go. Terrain patch, and I think I want to implement a method here in terrain patch that is get terrain patch vertices within this circle, basically. I think. But before I do that, I need to run FK around 5 minutes. I need to throw some stuff into the washing machine. So yes, be right back around 5 minutes. And sorry about this.
Okay, back. Sorry about that. And yes, indeed, Harukanen. Adulting stuff sucks. Most of it. Okay, where were we? Yeah, trying to visualize the affected points in a quick way. So yeah, each terrain patch should have a function. And each function should just take a world point for now. Probably in the future as well. A world point and a radius. And then the terrain patch will do all the work and just return the affected vertices. I had this idea that I would like to, so the visualization we're doing now, like just taking a set of 3D 3D spheres. I guess the word sphere implies 3D, but we take a set of sphere objects and we just position them at the world positions of the terrain vertices. And with the current implementation we're doing here, we're gonna do everything on the CPU. I had this idea that we could offload it to the GPU as well with a custom shader. The backside with that is that custom shader is gonna have to, in some way, get the height information. The height information is stored in textures that are located both on the CPU and the GPU. So maybe we could do some magic there, but we'll see. For now, we'll keep it simple, do most of the job on the CPU, and see what we can change later on. So what do we have here? Alter vertex data index based. Yeah, we have a few methods here as well that were only used for performance testing previously, and I think it was alter skip. I think alter and alter skip collider. Yeah, so this here we alter the terrain, including the mesh collider. Here we alter the terrain, but we skip the mesh collider. And these were used for performance testing, so this is not how it will look in the end, but whatever. Alter mesh collider cooking options. This one we used as well to test some performance, and unfortunately I noticed that changing the mesh collider cooking options didn't actually change that much. And we also noticed, I might need to write this up if I haven't already, that this one is the most costly one. And in this terrain solution we actually rely on a mesh collider, and updating that said mesh collider was the most costly thing. So, but it's needed. If we want terrain collisions to work at its best. Anyway, generate. Okay, so what I want is we want a get method. Although oh, here we have it. Have I yeah, I think I wrote this just to visualize or like give an example of how I would like it to work later on. So we're gonna uncomment this one and use it. So get vertices within circle origin radius.
Here we also we transformed the origin from world space to object space. I'm not entirely sure we need to do this, actually. So let's comment this one out for now, and then we have delta here, so yeah, I think we can do let's change this one into an array and do return, what did I call it? Grid point getter dot get grid point ranges within circle. Oh yeah, we return grid point ranges here. Welcome back, Fabic. How's the progress going? It's going pretty good. I had to run AFK as well for 10 minutes, just came back pretty much. But I think the progress is steady. So now the question is, do we want our visualizer to handle this or this? Let's do... Here's the problem again. So in the future we would like to only work with indices. Keep up the good work. Thank you. We'll try to. Grid points getter. Okay, I'm gonna do this. Public, public vector 3 get vertices from by indices. Return can we do indices dot select mesh data? Ooh, yeah. Native terrain, yeah. Mesh data I dot position dot to array. So we have a list of indices and we just return the vertices making up the terrain mesh for each indice. So here I would like to do the very, let's do okay, extremely optimized for now, but let's do vector 3 list vector 3 and then we do for each grid point range in
Oh yeah, we need delta as well. So it's delta, I think. Delta is vector 2 in this case, which is a little bit bad, but we just assume the delta is the same in both directions, which it should be. And for each grid point range then, so a grid point range has a start point and an end point, and remember these are in world space. Fuck, I do wonder. Get vertices within circle, origin, radius. Do we want to do this? Origin in plane object space. Can we convert it to... Can we more easily convert it to indices by doing that? Let's take a look how we create the vertices in question. We do this thing. So it's basically generate base vertex data at index, and we create the position like this. So we offset by 0.5 in X and Z. So if we do that as well, okay, we should be able to bring it back to indices if we do something like vector 3 offset is equal to actually minus 0.5 f. Let's see here. So by doing this, int start index is equal to, we do grid point range dot start point. Although, yeah, we do origin in plane object space, and that's the origin we use here. So now we are in object space. So if we do grid point range, offset plus this one. Okay, so this one is position in object space, but with the offset removed. Which means that if this start point is in the left bottom corner, this offset should make it so that this vector is 0, 0, 0. Jesus. And then we want to do, I think we want to divide it by delta. We're gonna go with delta x now. And we shouldn't need to round it, since these position in object space should be based on delta. Because we have, when we create them based on that is the question. Let's see. I divided by resolution, do dimension divided by resolution. Yeah, it should be right. Or is it? I'm gonna assume it is. And start index. Actually, let's do vector 3. So now we have, if I'm thinking about this the correct way, we should have a vector that has integer elements pretty much, which are the indices. And then we just want to do, so the index is actually truncated vertex dot x, and then it's the question of, I think we're doing, there's a lot of things going on right now. We're doing height first. Everything we need to care about is this, basically. So yeah, so given an x and a y, this is pretty much what we have. So start index, we should be able to use this one. So we should be able to do index truncated vertex dot x, truncated vertex dot z. But then of course we want to cast this to int and int. So then we get start index, and then I want to do Yeah, I want to do vertices dot add range, and the range we want to add is mesh data. Oof, this is rough. Mesh data. If you know that you're using int, then why not use vector3 int? Yeah, we could probably do that here. That's true. Good point. Does it do the casting itself? Yeah, we're gonna have to cast it somewhere, so might as well. Get range. Get subarray. Start and length. Here we do start index, and length we do grid point range dot number of steps, and then we do select md dot position, and can we do this? Okay. Yeah, let's go through this. Just double check. So basically, a lot of this we're hopefully going to be able to optimize away later on, but for now, this is what we do. So a terrain patch, get vertices within circle, an origin and a radius, and what we want to get in return is all the vertices within that. First of all, we transform this origin from world space to object space, so as if the terrain patch was located at Unity origin. We know that when we generate these meshes, we offset them by half dimension minus, just to get the grid centered around its local origin. So what we do is we take origin in plane object space, yes. So we just create an offset. And then we, thanks to this function, we get all the grid point ranges within the circle. So remember, these grid point ranges are a start position, an end position, and the number of elements between those. And for each such range, we take the start position, and what we're doing here basically here is we transform from a 3D position in object space to an index in the mesh array. And this is probably where we will get if we get an error, it's probably originating from around here, because what we do here is we offset the start point in the grid point range, and then we divide it by delta, but we offset it because we don't want negative indices basically. So we should avoid negative indices. If we don't offset here, we will have points that are on the negative axis. But then again, one sec. We don't want Yeah. So 1 point here, origin in plane object space. This one can have negative coordinates. We want to offset those negative coordinates, so we actually want to do this, I think, and then we add the offset. And then we get the index from this one. Yeah. And then what we do is, for this start index and number of steps, so from this grid point range, we get the position of the vertices in the mesh. And then we just add all of them together and to array. And yeah, it's a mess. But as I said, we will hopefully be able to avoid most of this later on. Okay. Let's just see what this gives, if we get any errors from this or whatever it is. Although I'm a little bit worried now that we do get grid point range within circle. Nah, it should be okay. So back in Action Terraform, what I want to do in update marker here is, for each terrain patch, we want to do for each, or do we want to work with in this? Nah, let's do visual point index. Let's do it for like this for now. For each micro 3 terrain point in do it like this now. If visual point index is less than Terraform visualization points dot length, visualize visualization points. And then we just do this. And in the end, I also want to do
Beautiful. Rough, but hopefully this will do the work we need right now. So basically, for each terrain patch that our marker is within, we do we get the vertices within the circle, and then we like take a visualization point, set it to active, and set it to that position. And we do that as long as we have points to spare, and or when we've done it for each terrain point, and then we just set active for the ones we don't use. Okay, so there's a lot of things that can go wrong here, but let's just try it. It's the first iteration, it will only get better. Yes, indeed. That's what I keep telling myself. Change visualize P. Yeah, we did. We altered this one as well. So update terraform radius, I think it is. So there we go. Worst case scenario, we get a never-ending loop and we have to restart Unity, and that's not so bad. And also, we might as well disable this one for now. Okay. A few things. We don't have any points, right? Or do we? No, we don't. Okay, so we screwed up pretty early on, I think. So, yes. I screwed up pretty early on by defining the number of visualization points to 0 and visualization point scale to 0. So I don't know, 50 and 0.01. Okay, we have a lot of points here. So these are our visualization points, and all of them are 0 and not available. So, and we never, yeah, because I never call this function. Okay. And I want to call this function like every time we call update terraform point or terraform point radius for now. Okay, now every call should be made. Let's see. Okay. Argument out of range exception, start must be bigger than 0. Parameter name start. So terrain patch 66. So yeah, the calculation for start index here is probably what's wrong. So we actually get a negative here, although start index, can this possibly return? Yeah, it can. Okay. Truncated vertex, we have negative values in this one, and let's see. Origin in plane object space. This one can be negative. probably help by either printing a few values here or checking them during runtime. Debug it. But let's see here. I just need to... I want to try and find my logic error before. So I thought this offset here would bring it back. Origin in plain object space. Yeah, so this one is world space. We transform it to local space. So at most, it should have a... like the bottom leftmost position it can have is minus 0.5 dimension x, minus 0.5 dimension y. So by adding this, we should be positive. But for some reason we're not, and yes, okay, so this can probably be... yes. But still, I must see, oh... yeah, okay, this is a bad spot to try and do this, to start testing our new algorithm, because we're right in the middle of 4 different patches. So I guess the error we're getting here is because we're at the edge of a patch. So although yeah, like by adding the offset here, our grid point range endpoint is definitely positive, but the start point might actually be negative, because we currently don't have any checks to check if the start or end range of these are within the grid. Like, this method pretty much assumes that the grid is endless. So hopefully we won't get this error if we stop playing here and we move the character, I don't know, to about here, or yeah. I say hopefully because I'm not sure. Okay, we get an error instantly here, and we have the same problem. It's very weird. Yeah, now we're not even close to the corners of this one, so yeah, something else seems to be wrong. Okay, for now, let's just check if start index is bigger than 0. I want to see if we get, like, if any of these succeeds or if all of them are wrong. Ooh, let's see, sphere, sphere. Okay, we have one sphere here. It's okay. We actually have. Fuck, are they just too small? We have some spheres being rendered, but where do we have character? Okay, so we're actually hovering above this patch, but we're getting spheres rendered for this patch. Right. And we get them rendered in the correct place. Are you aiding the patch position to the calculation? Ooh, you're definitely correct. That might be a problem. I'm also a little bit worried about all of them being rendered, but okay, let's do this. That's a nice point, Fabic. Let's change the size of them. I want them to be a little bit bigger. I don't know, 0.1 might do it. And yeah, that's true. So when we get the index here, we're working with, so when we do this, that 100% correct. So when we get the vertices here, this position is actually an object space, so we want to add transform.position here. So let's do vertices, add range. Let's add one of these. So here we want to do transform.position plus MD position. Okay, let's see this. I'm still... not a too bad result. It's a little bit wrong, but and also yeah, it works. It works a tiny bit. Wow. Actually, is there some logic to this? And like, okay, this is good. They are always located. Of course they are.
because we're fetching them from the actual mesh, so that's nice. But I would love to be able to sphere. Okay, here we go. We actually only want to show, let's see, how many points do we have in here? Very hard to see. 3, 4. Is the number of points correct? Yeah, that is what I'm trying to figure out. Let's do. Oh, it sucks that we can't see this sphere from the. Let's see. Let's do. Okay, and if we do I just want to be able to see what exactly we have within this sphere here. I don't think the points are correct. Or we have 1, 2, 3, 4. Oh, maybe. Let's see here. What is it? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we have 8 points within the sphere, I think. Yeah. That is not good. Okay, let's do this. Origin in plane object space. Let's take a step back and do get vertices within circle, origin radius. Change the radius and see what effect it has. Yeah, we can definitely do that real quick. I mean, this is interesting. So, I'm gonna try one thing here. We're gonna skip this part and just get the points from a grid based on this grid setup and show them. But I'm just gonna go and grab a cup of coffee, so 1 sec.
So we're gonna skip this part and just do, let's do this one. Let's bring this one up to here. And let's do grid point range. We're gonna do delta, we're gonna do origin in plane, object space. No, we're gonna just do origin here. And we're gonna do radius. And we're not gonna truncate it, we're not gonna start with indices. Instead, we're just gonna do let's see here, add vertices, add range. Let's do this. 4 number of steps plus, and here we do vertices dot add, and we just do grid point range dot start point. So this one is in world now. It's in world space since we do this. So we add this one plus number of steps, or I, times delta. So we're not going to get the correct height values here. Ooh. Delta dot x times vector 3 right, I think. And after all of this, we do return vertices. So what we're doing now, okay, to array, is that we calculate the grid points using world space, and we just return them like this. Do this really solve anything? Maybe. So now we should see points within the circle, but with non-correct height values. We just skip the whole converting to indices and getting... Yeah, okay, this is wrong. But we do get, they are at the correct positions. It's just that, let's see. Ooh, that's rough. It bothers me that we can't really see. I guess we can do this. We should only be able to see these 2 points, right? Ooh, okay, let's see here. It looks like the selected points are in double the radius. That is definitely true. I was thinking something similar, and then we're truncating this position here. So this one, we're truncating it back to here. And if we have a sphere here with double, then we should be getting yeah, we're truncating. It's a little bit weirdly offset as well. I think we're truncating it to here, and we double radius definitely. Slash the calculation radius by 2 and see if it helps. Yes, let's do it. I'm just thinking we have a tiny bit of a weird offset as well, which screws things up. We're actually I think I'm gonna truncate this visual sphere as well. So we're gonna truncate it to the grid. And we're gonna make the radius half the radius, yeah. Yes. It's definitely. So action terraform. Radius. Terraform point scale, yep. Get vertices within circle, terraform point scale. Let's do 0.5f, multiply here. And then I also want to do terraform visual point, transform position. So, not this one maybe, but update terraform point. When we update the terraform point here, or use vector3 int for the truncated value. Yeah. Probably gonna do that in the future. The thing is that I think depends on, let's see here. With the current implementation, it's not entirely certain that each vertex is located at an integer value in the terrain. So actually we have 512, 512, so it should be perfect integers. So we could do integers, but it's like a special case. If we instead, like, yeah, we have our terrain is 512 times 512 units or meters, and 512 times 512 vertices. But if we go double these, our vertices are not located at integer-based positions. So, but what we could do is both solutions would work, but okay, update terraform point. Here we set terraform point to new terraform point. I think for now we're just gonna do divided by yeah, terraform point yeah, but Fabic, you're also correct. Like right now we could just do, we could go with vector 3 int, but let's do terraform point dot x. Let's see here. So what I'm doing now is that we round it to the nearest integer, but this will only work in our current case because our dimension and resolution are the same. What's up, CoolerSK, by the way? Yes, Pinkgrass madness indeed. So now we have truncated this terraform point as well, so it will always be located on a terrain vertices, I think. And we have halved, we have half, or we multiply the scale by half to get the radius. So the scale is actually the diameter. Almost. We don't get the endpoints here. We don't get the endpoints because I screwed up. Like, yeah, okay, because of this one, right? Thank you for the donation, Fabic. Appreciate it. You're too generous, man. Too generous. Yeah, this... Oh no, I screwed up again. Or do we... Wonder why we did include these points this time. Thank you, Fabic. Appreciate it. I'm hoping to get the first signed copy of the game. You definitely will. But unfortunately, that is a bit into the future. Okay, so this, why... And is it logical that CoolerSK guesses that it will be released in 2030? Hopefully a bit earlier than that. Hopefully. Why... Does it make sense that these are included? If the radius... We're definitely closer. Okay, here it makes sense. Fabic, I have time. We'll be watching the progress. You can bet on that. Nice, appreciate it. You're always welcome to watch the struggles. hope dies last as well. Yeah. Okay, we're almost there. Maybe play with errors / correction values. Yeah, we'll take a look. We're almost there. Oh, this makes... Okay, these points make sense. These points makes sense. Fabic, what struggles? I just refer generally to my work here. Sometimes it's a bit of a struggle, but always moving forward. But okay, so this result is beautiful. So truncating the center of the visual sphere and also doing half the radius, or like multiplying the scale with half to actually get the radius. That was a nice input. So this is the correct result because our algorithm that checks for these points, it doesn't actually know about the sphere. Like it doesn't know anything about this visual sphere actually. It just gets the points closest to this one. So yeah, the result we're seeing here makes absolute sense. Okay, love this. Love this. Oh, I want to... Let's try and see what we get here. Very nice, I think. Okay. Okay. Let's see. Okay, so that's... Now we know that the... Doing this works. So that's the first step. Now I want to do this again, basically, but I want to do it with origin in plane object space. Let's see, when we truncate the circle and also halved the radius, let's see what kind of result we get from this again. It's probably not perfect, or the correct one, but maybe we can get some like information of what is probably going. Did I forget to remove something? This looks too good. But then again, we don't seem to be... like... Okay.
Are we actually getting... I'm a little bit... Or did I forget to run it again? Like this result... I like what I'm seeing here. My only problem with this one is that we don't seem to be getting the correct heights, right? But other than that, we're getting the correct result, and that is with this one. So we do origin in plane, object space, radius and delta x, truncated... Am I missing something? The fuck? Devioli, so applications is sent. Oh, good luck. How do things look? It looks pretty good over here. I'm a little bit... we actually seem to get the correct result of this one. I wonder, however, why... we're not getting any height difference yet. Yeah, something is wrong here. All the points Y position is set to Y1 in the inspector, yeah. Why is that? We should be getting a position that is non-1 here. Like I'm starting to question if this one is actually running. Yeah, one sec. But then we set the position here. Now we set the height, so why oh why? Get subarray. Oh, let's see here. I don't get it. Get subarray, and then we select for each. I want to see, can we do... Yeah, okay. I don't get this. I don't get this at all, actually. Get vertices within circle. Let's see. And then we get them terrain point, and we take the full point. We don't skip Y. Very intrigued by this one. I'm also a little bit... Let's see. Let's try and print something here. Let's do debug.log, and I want to print mesh data start index dot position. Very interested in this. Yeah, okay, this makes more sense. Yeah, this was what I was worried about. I don't know what happened, but I think we didn't run... We still ran this code? I don't know, did the changes not... It gets rounded to 1. Now we actually have the different Y values here, but now we don't have the correct vertices. So what I think unfortunately happened, I don't know why, but I guess it didn't recompile correctly because this one didn't run. The old solution ran, the new one did not run, and that's why we had. Makes no sense. So this is the old one. Here we don't have any Y values because we don't use the vertices from this one. And if we comment this one out and comment this one in, we get the wrong result. And it has to do with the how we get the indices, I think. But it doesn't look too bad. Just some very simple. So now we get the correct Y values, but we get the incorrect terrain points. And y. So let's do some more tries here. The first thing we do is origin in plane object space. Okay, I want to do, let's comment this one out again and comment this one in. So this is, we just doing it with purely the world coordinates. I want to try and do it with origin in plane object space here. So now we have object space here instead. And when we add them here, I want to do transform.position plus. So we transform the origin of the circle to object space, and then we calculate the grid points based on object space, and then we transform it back to world space by just doing this. This shouldn't be where the problem is occurring, but I just want to make sure it's not here it occurs. We actually have a problem here. We don't get any points. Or we get them, but okay, we're way down here. Yeah, because the point in object space is down here. Okay, yeah, so this is not where the problem is happening. So here we transform it to object space. We get some negative values. Yeah, I'm pretty sure this is where. How about instead of multiplied by vector right, use 1 height 0. So you're talking about here. Oh yeah. Like if. Yeah, so the problem, like with this solution, thanks to us doing this is why all of the points share the same height value, definitely. So we could fix it by reading the height values here. The only thing is that I would really like to take this D course here, or whatever you call it. I do want to convert it to indices and then fetch the vertex values. Although I wonder, origin in plane object space. Cold Bones, yo. Okay, I'm just gonna pull up a image editing software here. I just want to make this make sense. Like, this looks to be semi-correct, I think. Does it? Like, we generate the mesh in object space to be like this, which means that these are negative x and z, negative z. And when we do offset plus grid point range start point, so what this offset here is supposed to do is move all of this to be located, where is it? Here instead. So we only work with positive values. And that means that a point that is located here gets located here, so at 0, 0, and that should be, and then we should be able to just convert it into an index by doing this. But that doesn't seem to be the case, because I don't know why not. Start point here. Ooh, let's see. Ketolenoxy, okay. Okay. Truncated. I don't see why this wouldn't work. Ooh, no. Nah, it should be. Or actually... I don't see it. What do we actually get by this solution? Okay, this is the old one. Yeah, we don't actually get a recompile there when we like uncomment a couple of lines. That's weird. I mean, it's semi-correct, I suppose. It's this whole phase of switching it to index and then back. 4 positions, 7 points. Yeah, I think a few of them get removed thanks to this one. Like, we have the issue of still getting negative indices here, even though we have this one, which I find... Ooh, nah. Or... nah. What if... Okay, I just want to try and... What if I get grid points within circle? We already tried this, and this gave the correct result. If we No, it should be okay. Yeah, so, like, this, we do get correct grid point ranges here, but they are in object space, including negative positions. And we want to take these values and change them into indices. like this. I wonder if offset plus dimension. Now, like I said, this should bring it from the red to the purple. So we should only have positive values. Should, but we don't. Because something is wrong. Could it be? No, I don't think so. Offset y equals 0, start point y equals 0. Yeah, the idea is to set the y value here. Like, here we calculate, let's see here. Here we get the grid point ranges, here we truncate them, and here we convert them to indices. And the idea is then to read from the actual mesh data using this indices. Which means that when we read from the mesh data, this position here has an offset or a y value that is offsetted. So the problem isn't really that, like if we do this solution, here we just ignore indices and we just calculate grid values. Here we get a y value of 0 because this one doesn't know anything about height. Down here, however, we try to read vertices making up the mesh, so we should be getting height values here. And we do. If we take a look at the points we have here, they actually have a correct height value, but they are not the correct points. And that is because we don't calculate the index correctly. But I don't see in what way we or I fail to calculate the index here. But then again, okay, I want to see debug.log truncated vertex. This one shouldn't have any negative values, but I think it does. Actually it doesn't, so what the hell? Okay, this one looks real good, I think. This is exactly what we want.
4117. Actually, we have an error here. Did we get this one now, or? Yeah, okay, when we're outside, and that's okay. So what is... So the indices we get here seems to be all right. So let's do start index as well. Send you something on Discord, sir. Yeah, I'm gonna take a look. Just gonna see what kind of value we get here first. Yeah, we don't get any negative here. Let's see. Ooh, okay. Thank you, Fabic. Appreciate it. Let's see. I'm trying to think. Oh yeah, have I just screwed up? Let's see here. My array has a width and a height. Yeah, I think
it's pretty clear. I just need to figure this mismatch out. So everything works up to this point. We have seen it here. So the problem is happening here. And that's on me. Simple converting it. So from an object space position to an index. So we can properly... although... Nah. So we can properly fetch the correct positions. I thought I had it, but I don't. But yeah, as usual, unfortunately, that is going to have to wait because I need to run. I will continue this madness tomorrow, and hopefully I will be able to stream a little bit more starting next week. Or longer, I would say. Yeah, but I still think there was good progress, and I just couldn't really get this down. But yeah, hopefully I will see you all tomorrow, and I just want to say thank you so much for watching. It's really appreciated. Thanks for the donation, it's also very appreciated. And yeah, have a great rest of the day.